Okay, so we're gonna find now the second derivative. I'm gonna use the first derivative. The function ended up being 3x squared minus 1, so now I'm gonna find the derivative of that function. And I set it up here as the limit as h approaches 0 of f prime of x plus h minus f prime of x. I'm gonna replace instead of x plus h. It ends up being squared, so I'm gonna actually find what that is and then distribute the 3's. The minus 1 with the plus 1 that came from here cancels out, and then I notice that the 3x squared also cancels out. Again, h divides this term and h divides that other term, which makes me which leaves me with 6x plus 3h. Now I'm free to evaluate. H equals 0, so this is just 6x. So f double prime of x equals 6x. So the graph of the three curves are right here. The original function f is this cubic function, the derivative is a quadratic, and the derivative of that is a linear function. So notice how a function that has a degree 3, when I take the derivative, gives me a function that has degree 2, and when I take the derivative again, it gives me a function with degree 1. So that always happens. For example, if you were given a function that has degree 4, then the derivative will have a degree 3, the second derivative will have degree 2, and so on. So what is the relationship between those? We're going to see that in the following animation. Okay, so I have the function y equals x cubed. So notice how if I draw the slope of each line, if I follow my little car, the slopes here are all positive. And then at 0, I have a slope of 0 because the tangent line will go across. And then in this part of the graph, the slope is still positive. So it does make sense for the derivative to have all positive values and then 0. So it is very positive. It is very positive in this other direction, and then at the 0, the derivative is 0 as well. So now let's look at the slope of the tangent lines over this one. I'm going to turn off the original one. Now this is the first derivative, this is f prime. Now let's see how the slope changes. The slope on this branch of the parabola is positive. The slope on this side of the parabola is negative, and then naturally here the slope of the tangent line is 0. So let's show the second derivative. So for this branch, all these y values are positive because the derivative is positive for the blue curve. In here, the derivative is negative, so that's why this line has y values that are negative, and you can see those negative y values there. And naturally, as x approaches negative infinity, the tangent line gets steeper and steeper. That's why the y values in here are getting lower and lower and lower to negative infinity. So that's the relationship between those three graphs of f prime, and f double prime. So it says that we can interpret a second derivative as a rate of change of a rate of change. So as I take more derivatives, it's the rate of change of the rate of change of the rate of change of the rate of change. The simplest example that we have is acceleration. For example, I may have a distance versus time graph, okay? And let's say that it's that x cubed that we saw before. The derivative of that would be velocity. So how does the velocity change respect to time? It will be just like that y equals I think it was 3x squared. That's how it changes the velocity. Now the derivative of the velocity respect to time, or the second derivative of distance respect to time, will be called acceleration, and that's the one that changes like this and it's linear. So the derivative of distance respect to time, velocity. When I take the derivative again, I get acceleration. So here it says it, velocity respect to time is the first derivative of distance respect to time. And then I could write on this next slide, acceleration is the first derivative of velocity or the second derivative of distance. First derivative of velocity or the second derivative of the distance. And then we can have a third derivative of that, or we can have a third derivative of acceleration, and I think that's what that phenomenon is called a jerk. Is the third derivative of distance respect to time, or is the first derivative of acceleration respect to time. For higher derivatives, I show you that we just write the number between parentheses and it does not mean power, and the notation as a ratio would also be done like this. So if I have the 10th derivative, I would write this like this, the 10th derivative of y respect to x.